Hi guys. Right now I'm in Memphis, actually in a hotel room in Memphis. Sorry about the background uh, behind me. So today I will give you kind of a brief um, summary of the future development or the advancement of additive manufacturing from my perspective. All right, and this lecture will be shorter than those regular ones because we pretty much covered a lot of content already. So this class will be quite brief and short. All right, let's start. Let me share the presentation. All right. So in my mind, the future directions, the future feasible directions for additive manufacturing could be categorized as few different directions. The first one is the support of personalized fabrication, right? So the user of additive manufacturing will be not only just the designer and the manufacturer, but also it could be the average people. So people who may not have the strong background in design, manufacturing, and even engineering. So basically, they could convert their innovation, their ideas through the computational tools, and then additive manufacture using those personalized additive manufacturing systems. And the second future direction for additive manufacturing is the design for additive manufacturing. So that also consists of different aspects, and I will introduce more details in later slides. Sorry. The third direction is the so-called printing it all manufacturing process for functional product. So basically, not only just accumulating the material for additive manufacturing, but also to embed the functional component during the printing process, and also direct print those functional objects. So that's the idea of the so-called print it all, and I will show you some examples there. So the last but not the least important direction is the large-scale additive manufacturing. So we have the kind of those regular size additive manufacturing. We have those smaller micro nano level additive manufacturing, and also we should have the large scale additive manufacturing for those buildings, bridges, and also some other large facilities which can be additive manufactured. Okay, let's check some details. So the first is the personal additive manufacturing systems and services. And if you can see, if those manufacturer systems, I chose some of these representative of systems, like this MakeBot, right? It's very popular during the among the people in makerspace and the DIY community. So basically, it's a desktop level fuse deposition modeling systems, which cost around 1,800 something. So that is the basically the kind of personalized fuse deposition modeling systems. And also there are even cheaper ones like the one shown here. So basically the Delta 3D printers, which is only around 300 something, 350, which is quite affordable. And people could purchase this and put it in the garage, in their garage, or just put it to some desk. And then once it's connected to computer, or you just insert a SD card, you can 3D print it. You can 3D print the object you want, right? And this Formlab is the most popular desktop level stereolithography additive manufacturing systems, and I have one in my lab. It's pretty good, and the printing is quite precise. But the only thing I would say drawback is the workspace. The printed object is relatively small. Yeah. Oh, by the way, we also have this even smaller fused deposition modeling systems. This M3D macro 3D printer also costs around 350, right? For other printing process, like the one shown here, basically it's a stereolithography, a selective laser sintering printer, which can print object with the plastic powders or nylon powders. Although it's relatively expensive than other systems, but still, if we consider about those its full size counterpart, right, which usually cost like $500,000 or 300,000 something, this is quite a reasonable price, and yeah, it could be a good facility for a university lab, or I don't know, could be the facility for a high school or community college, right? So another very, I would say, a remarkable system is this Markforged carbon fiber reinforced additive manufacturing system, right? So this one only cost around 4,000, and it has the capability to print object with nylon base, but carbon fiber reinforced internally, right? So not only these manufacturing systems, but also the online service will support the personalized additive manufacturing. Basically, people can access those additive manufacturing systems either by using these online desktop or personalized version of the additive manufacturing system, or they access them using these online services. So this really enables the possibility of so-called personalized manufacturing, right? So that's the support of personalized additive manufacturing, right? So the second one is the design for additive manufacturing. So it consists several aspects, and let's check them one by one. First of all, this one is kind of a relatively new. Basically, just remember what we talked about last class. So basically, we talked about some 4D printing, right? Basically, the object can be printed in 2D pattern, right? And then applying some activation like heat or other like magnetic field, such so on and so forth. And it turns out this 2D pattern can self-fold it back to some 3D thing. So definitely it requires a lot of computational support there. So basically the research will be how this 2D pattern look like if you have a 3D design in your mind, right? And also different materials and different mechanics to realize this self-folding will be a quite interesting direction to think about. Actually, let me show you these work one by one. So this one shown here, so the left one, basically is a self-assembly shoes, and which is demonstrated by the MIT self-assembly lab. And basically they print another different material, which is more rigid onto this elastic textile material. And first, this material is stretched out, and after printing, the stretching is released, and then it will self folded back to a 3D shape like this. So it's quite amazing, right? So another possible direction is print these electronics inks or conductive wires onto those fabric. And some electronics functionality, uh, electronical functionality could be achieved by doing so. And some kind of a functional garment like the one from the sci-fi movie Tron could be realized, right? Actually, I'm also doing some related research along this line. And let me show you the video. Um, Basically, this one. Right? So we have this stretched out, this fabric stretched out, and we print the patterns onto this elastic fiber. And let's see what happened after printing. So just release the stretching. You can see basically the restore force will generate some 3D patterns, right? And if you change the pattern here, then different shape, 3D shape could be achieved, right? You can have this kind of a curved shape, right? And let's see what this look like. And after removing all those excess material, you have something like this and like this, right? It's quite neat, right? Quite neat idea, right? And but not only this kind of a fabric is used, but also some other possible material and mechanisms are explored, like the one shown here. So basically, in this work, the DNA are utilized to form this complete origami joint, right? As you can see, basically it fold the original pattern is like this, and you have this and this two different folded patterns. And also this self-folded folding robot is also is also developed by the MIT DRL lab, and the kind of activation force for this is the magnetic field. So that's also very interesting. And also this one, I think I showed you before, and that is the polymer-based kind of self-folding additive manufacturing, which is done by my colleague and my collaborators and myself. Right? By heating up the 2D patterns, it will fold back to this 3D shape. So this is one, I would say, promising direction, and of course, it requires a lot of research on it, just like what I mentioned in last class. All right. Okay, let's move on. So another one is the structural optimization, the topologization, right? So I mentioned this a lot during the class. And again, other than structurality, those other objectives could be optimized, like this topologization for the fluid dynamics, for the optimized fluid dynamics. But some other requirements, such as the thermal distribution, heat distribution, or so on and so forth, could be also optimized. And another one more step is kind of you have multiple objectives. Then how to properly set up your optimization such that you could satisfy as much as possible of each of these objectives. How to play with the parameters in the optimization such that you can have multi-objective satisfied, so on and so forth. And these are kind of in macro size, right? But topology optimization is also capable for the micro or even nano level of modeling. So some examples like this, and as you can see, this annotation here, Basically, these structures very neat, and they are in the either micro level or even nano level. So you can see this kind of structure repeats itself, and it brings the unique material properties to the final shape, to final object, right? And actually, this kind of object, this kind of structure actually is manufactured using, I would say, the stereolithography related additive manufacturing process. And these figures shows how they actually manufacture them, right? Of course, it requires very high precision because this kind of a structure is pretty small, right? But it's durable if you have a very focused laser or UV light. Right? Other kind of example of along this line is this scaffold optimization in a macro level. So as you can see, this kind of a hollowed shape is generated and optimized, the size, the shape, and so on and so forth, right? Also, this unicell structures. Basically, this is the uni-distributed, uni structures with the same size and distribution. But according to the load and the boundary conditions, the size and distribution of these unicell could be varied, like the one shown here. Apparently, these are larger and sparser, and these are smaller and denser. So play with these will bring the better structurality or other functionality to the material. So, but these are in those macro or even nano scale. So that is kind of another different application for structural optimization other than the macro scale ones, right? Other than that, again, we have this material modeling, digital material modeling, because many of these manufacturing process like the HP's jet fusion printer or the Stratasys, the polyjet printing, they all use the so-called voxel-based modeling. Basically, it discretizes the 3D object into all the small cubes, and you can set up material properties and other like conductivities and other properties, and even color onto each of these cube. Cube, and but how to effectively set it up by user, and how to reduce the memory and the computational requirement. That's really essential problem to solve. And also even the design interface for people to easily define or specify the material, different colors or different other properties will be essential, because right now it's pretty difficult to do this, and it's slow, it's not interactive speed, and do that is quite tedious. So how to easily set up these for those corresponding additive manufacturing process, that will be another, I would say, a feasible direction. All right, and also again, those customized products, especially for biomedical products, right? So these kind of customized biomedical product will bring the benefit for the patients, right? It's usually will have better performance, shorter time for the recovery of the patient. But again, the shape is unique because different people have different body shape. How to customize them, how to make the product perfectly fit to an individual, right? And that's the direction to pursue. And what will be the design methods to enable the customization, right? And how to optimize the design. These are all questions for in this direction. And yeah, it's also very feasible. And you can see a lot of applications along this line, not just some research, right? All right. So the next is the functional printing, right? We have, I don't know whether you still remember or not, I introduced one of my work, right? So basically in that work, we just embed the functional components in a cuboid, and then the geometry will print it by revolving the cuboid base and print on it. And but that is just some attempt to the final goal, that is print the full functional object during 3D printing. So some possible scenario for that is basically you have some idea like the one shown here. You want to have a customized doorbell, like it looked like a night owl, right? And you want this doorbell has multi-functionality, like it could talk. Of course, there's a louder speaker, talk to your guest, right? And also that it could have a camera to see the face of your guest, or it might have some face recognition functionality there, and it tells you whether this is your friend or not, so on and so forth, right? And but once the user has this idea, she or he can design it through the computational tool here. Definitely that this computational tool should be very easy to use without those complex operation or domain knowledge, right? So after this computational tool is used to design the functionality by a simple interaction, the robot manipulator based system will automatically plan how to do the printing. So the layer could be curved, or the whole part can be decomposed into different sections. And printing each of these sections will not require support, and so on and so forth. And more importantly, during the printing process, another robot manipulator could install the functional components into these 3D object. So after printing, you have a fully functional object. So we achieve the direct out of 3D printer functionality. So that's the story. That's the idea of along this line. So it looks, it sounds very interesting, right? So it enable the user to actually generate some functional object automatically, right? It sounds like some story from a sci-fi movie becomes true, right? Yeah, I'm also excited about this research, and I will keep on working on it, right? So another kind of piece of work is the automatic functional, I mean, this kind of kind of electronics component printing. So like the dice showing here, basically these wires and components are embedded and printed during the printing process. It directly, I mean, these materials, conductive inks, are directly deposited onto the 3D object during the printing process. And this one shows a antenna, right? So it's also the conformal shape, I mean, conductive wires are printed. A similar case happens to all these. But I want to put more words on this. So basically, this one is different from all the other examples because this material is flexible, so you can see it can be stretched. So, but all these ones are, I mean, the material of these ones are rigid. So you can, from this one, you can see some possibilities for those variable devices, right? So those this variable interaction interface, or some sensors, right? Variable sensors, and so on and so forth. And also this one actually is generated by a low cost systems, the Voxel 8, right? So, but still it achieves the direct printing of electronics and conductive wires. So I would say this one is also a very feasible direction to think about. Okay, let's move on. So the last piece of work is the large-scale additive manufacturing, right? So there are some examples showing here. All right. I mean, for this tube, I mean, you guys are, I believe you are quite familiar with this, right? Basically, the additive manufacturing capability at ONNL enables the printing of a large scale objects like this house or this car, right? So basically, these are also a future direction to additive manufacture those larger scales ones, right? Which is as large as something like this and this. So these are really amazing to people. So basically, not only just some desktop level stuff or those smaller stuff, you can print a full size car or even a house, right? That will change the world. Another example is this one. Basically, I don't know, I don't remember who pointed out, but is also another. I mean, in the last class, some of you kind of found this and shared the link during the class. So basically, this is also a very impressive project, right? So basically, the professor Neri Oxman from MIT, she kind of developed this project. Basically, this large-scale robot 3D print a house, right? So as you can see here, it deposits some concrete like a material other than the plastic or a kind of polymer, right? And it turns out this become a house for people to live. So although it's kind of still in the early stage, and but I would say it is the future for the large scale additive manufacturing. And another piece of work shown here, basically, this figure gives you some illustration about the possibility that people do the Mars cloning, right? But how to build the facility and house? Then you need some building robot and do the additive manufacturing on Mars, right? I mentioned this before to you, right? It's kind of, well, although we have a lot of things unsolved on Earth, but we should always look at the stars, right? Kind of think more and think farther, right? All right, I think we just done about this class. I mean, all the lectures are done, and the rest thing is to have your presentation, final presentation, and a report submitted, which is which will be in next week's lecture on Tuesday, right? I mean, I would say for going through this class with you guys is a really valuable experience for me. And I feel grateful for what I experienced in this class. Especially, I enjoyed the discussion with you guys and talking to you guys, share the knowledge and kind of experience with each other. I really enjoyed, and also I learned a lot from you, especially for some of these metal process, because personally I never worked with these systems, so there are a lot of things I just don't know, right? And hopefully you guys are working on. I mean, thankfully you guys are, some of you are working on those metal additive manufacturing facilities, and some of you have a lot of experience on other manufacturing systems, right? And all of you have, I would say, much more experience on the operation, on the manufacturing, on the design, and all of these really benefit this class. So we have very fruitful discussions, and I can see how you learn from me as well. To be honest, such as how to define a research, right? How to kind of organize your work, your project in the way that a research should look like, right? I can see the improvement from the very beginning and your last, the midterm presentation. And hopefully we will have a very successful final presentation and a report. Actually, I believe we will have a very successful presentation and the project. And hopefully you will learn, and you learned something from this class. And all right, I may stop here, and let's meet next Tuesday, and let's have this class have a good finale. All right, bye guys.